on synchronous clocked sequential circuits. Okay, and we'll see some of the examples today. Like in the previous class, I have just shown you the millisircuit model, and in this class I'll show you one Murray circuit and millisircuit as well. Okay, with all those 7 steps we have to follow to find out to get our sequential circuit. So our question would be look like this. So it is like 10 mark question, students. What you have to do, the question will be realize the sequential circuit, realize the sequential circuit for the state diagram given. State diagram given below. So here the state diagrams look like this. Okay, here you can see how I am doing. Okay, so this is the state diagram. By looking into the state diagram, what do you understand? This is what type of model? Obviously, we can understand that this is actually the Murray model. Am I correct? Murray model. Here in this Murray model, you can say this is my state, okay, and this is my output, and these are obviously my inputs. Okay, so here it is something about different type of things are there. You can able to see over here. Here the inputs are, you can see x equal to 0, x equal to 1. It is going to present state A to B. Okay, are you understanding? So here if input x equal 0 and you are presently in this state, then you will go to the next state B. Okay, even if your input is 1, if you are in present state A, you will go to next state B. Okay, and for both the cases you can see here you have output is 0. Here B, for state B output is 0, for state C output is 1. So here you can see how many states are there. Mainly A, B, C, 3 states are there. Okay, so we're going to start the thing. We are going to, what we are going to do, we are going to realize the sequential circuit for the given state diagram. It has been given to you state diagram like this, and this is obviously a Murray model state diagram. Okay, from this we are going to design our sequential circuit. So what is my step 1? Obviously my step 1 is obtain the state table. Okay, obtain the state table from the given circuit information or the state diagram. So here we have been given to us state diagram. From that we have to find out our state table. As I told you, the state table consisting of what? Present state, okay, next state, okay, and your output. Okay, so these are the 3 things will be there in the state table. So in the present state, you can see what are the things will come up mainly in the present state. There will be either you will be in this state, or you will be in this state, or you will be in this state. So obviously your present state will be 3, A, B, and C. Are you understanding? So what would be my next state? My next state will be, if for input 0, I am going from present state A to next state B. If my input 1, I am going from present state A to next state B. So obviously the next state would be obtained for input x equal 0 one next state, and for input x equal to 1 another next state. Are you understanding? So for both the cases I would have different next state. So if input is 0, I would be going from present state A to B. For input 1, I would be going from present state A to B. Okay, for you can see here, if you are in this present state now, for input is 0, you are staying in this present state C, next state will be C, and for input is 1, you are going from C to A. So obviously there will be 2 possibilities of inputs. X equal 0, you will go to present state A to somewhere else state, and x equal to 1, input equal to 1, at that time we are going to somewhere else, and output is obviously Y. Okay, so we'll do those things. What we can do actually, now I am at present state at A. So I am at present state now A. Okay, please see here how I am doing present state A. For input is 0, where I am going mainly? I am going to B. For input is 0, I am going to B. Okay, for input is 1, where I am going? Again B only. I am at A now, I am going to B only. Are you understanding? So this is my next step B. And what would be my output for A state A? My output is 0. Very simple. Understand? The next step. Now I am in which state? I am in present state now. Let's say B. Let's say I am in this state now. Okay. For input is 0, where I am going? For input is 0, I am going to C. So that only I am going to write down C. And for input is 1, also I am going to next state C only. Are you understanding? And what is my output? My output is here 0. So this is my output. Output is 0. Now I am at present state C, let's say. I am at present state C. So input is 0, where I am going? Input is 0, I am going to C only. That only I am going to write down C. And for input is 1, I am going to C to A. So I am going to A. And what is my output? My output is 1. Okay, my output is 1. So very simple. So what I have done here, I have just derived or obtained my state table from where? From the given state diagram. Now what I have to do? Step 2. So do you all understand step 1? Step 2 is state reduction. So you can able to do state reduction or not, you can see here. So there are how many states here? A, B, C, 3 states are there. Can we able to reduce the number of states? So you can see there is no possibility of state reduction. Why? For this present state A and this next state B, B, C, C, A, C, A. So is there any for any of these states, is there any repeatability of next state and output? No. So you can understand here that my state reduction is there is no possibility. There is no possibility of state reduction. Okay. In the next question, you can able to see how we can do the state reduction. Don't worry. State reduction. Why? Since no two states, next state and output are same. Outputs are same. Are you understanding? No two states. So there is A, B, C. There are 3 states. Here, no two states, outputs and next state will be similar. That's why no state reduction is possible over here. Okay. So do you all understand now? So step 2. Now we'll move to the step 3.
Sir, once you say step 2, no, sir.
Okay, step 2 we want. Okay. So step 2 is what? Mainly, is there any state reduction is possible or not? So what do you mean by state reduction? State reduction is there are how many states now? A, B, C, 3 states. Okay. If you can see, instead of this, here it has BB, here it is CC, here it is CA. But instead of this, here it is BB, then we can able to reduce this state B. Okay. But here no two states having same next state and output. Are you understanding? So that's why state reduction is not possible. Okay, no possibility of state reduction. Are you understanding now? So how we can have state reduction? When we can have state reduction? Let's say here it is also instead of CC, it is let's say BB. Now you can see this state and this state have same next state as well as output, same next state as well as output. So you can reduce this B, you can remove this B. But now it has not possible because no two states have same state, next state and the output. Are you understanding now? So you cannot do this. So this is CC, you cannot do this. Okay. So AB are of different set, BC also different state, AC also different. So we cannot reduce this ABC states from here. Okay. So that's why no possibility of state reduction because there is no two states, next state and outputs are same. Understand now? Those who have asked me doubt, did you understand now?
Yes, sir.
Okay. What is step 3? Step 3 is state assignment. State assignment. Okay. So what is state assignment now? State assignment is nothing else. Assign the binary values to the state. So you can see here state is A, B and C. So what you need to do? You need to assign those A, B, C into binary values. So now you can see how you can assign it. Assign the binary values to the states. So here we can come to know that we cannot able to reduce my states from ABC. So here how many states possibility? There are always three states ABC. So how you do assign that? For in order to assign these three states, I need how many number of binary values required? I require two binary values. Because why we need two binary values? Because this can be assigned with 0 0 0 1 and 1 0. Okay, so that's why this is the way you can do state assignment. Assign the binary values to the states. Understand now? So step 3, all of you understand? Because here my states are in ABC, so you have to assign those ABC in particular binary values. In order to assign three states, we need how many binary values? Binary bits, two binary bits. Because one binary bit only can be represented as 0 and 1. 0, if there are two states, we can assign A to 0, B to 1. But here three states, so in order to assign these three states, we need 2 square 4 number of binary terms, which are 0 0 0 1 1 0 and 1 1. From out of these, 0 0 will be assigned to A, 0 1 will be assigned to B, 1 0 is assigned to C, and 1 1 is not there, so no need of any assignment for it. Okay. Now step 4. What is step 4? You need to identify number of flip flop required, and you have to also decide what type of flip flop you are going to use to design that particular sequential circuit. Okay, so here main thing is, as we know that in the question, if it has been given to you what type of flip flop you are going to use to design that particular sequential circuit, that only has to take. But here in the question, it has not been given to you for this particular sequential circuit what type of flip flop you are going to use. So obviously your wish, what we can take actually, either you can take D flip flop, you can take T flip flop, SR flip flop, JK flip flop, your wish you can take. But here, if in the question it has been predominantly given to you, design the sequential circuit using your T flip flop or D flip flop or SR flip flop or JK flip flop, then you have to choose that particular flip flop. But here in the question it's not given to you, so you are now boss, you can choose anything. Okay, any flip flop you can use to design the thing. Understand? Or any doubt, students, please let me know. Do you have any doubt immediately? Aishwarya, I have any doubt?
No doubt, sir.
Okay. If there is no doubt, we'll go for the step 4. So step 4 is number of flip flop required. As we know that one formula, 2 to the power n is greater than equal to n. So here n is called number of flip flop required, n is number of states. So here we can come to know that after reduction and all, not at all possible. So we have how many states? 3 states. By looking into this, I can able to find out my n equal to 2. Okay, do you all understand now? N equal to 2. So from this we can come to the that we require flip flop required to me to design this particular sequential logic circuit is 2. So now what type of flip flop? You can take any type of flip flop, your wish. So I can take, actually already I have done with that D flip flop. So now I can take my type of flip flop is actually T flip flop. Okay, so T flip flop I can use, and I require two flip flops, two T flip flops to design this particular sequential circuit. Okay, understand now? So next, so n equal to, and type of flip flop I have decided to take is T flip flop. Okay, so these are the two things I have achieved in step 3. Step 4. Now step 5. What is step 5? Step 5 is you need to find out the excitation table and the circuit output table. So what you need to do, you need to find out the excitation table and circuit output table. Okay, in this excitation table, what will be the students? As I told you, in the T flip-flop, you are taking a T flip-flop for your design. So T flip-flop excitation table is what will be there in the mainly in the excitation table. It has present state, which is nothing else q1, and it has next state, which is nothing else your q1 plus 1. Next state is nothing else your q1 plus 1. Okay, after that it has out input flip flop input t. So this is 0 0 0 1 1 0 and 1 1. Okay, so this is I am taking for the t flip flop. As you know that what is t flip flop tells, t flip flop is nothing else my whatever my present what would be my t flip flop this thing. You can see here 0 0 is 0. It just look like a xor table. Okay, all of you know this. The t flip flop is what? T flip flop is nothing else. Your truth table of t flip flop look like this. Okay, 0 it's 0 it's q1, 1 it's toggle. Okay, q and bar. So according to this I have just find out this excitation table, nothing else. Okay, so after that what you have to do, this is actually one single flip flop excitation table, but we need excitation table of complete circuit. Okay, so how to do this excitation table of the given circuit? You need to find out excitation table of the given circuit. So you can see here what you can do. So it has actually present state, as I told you. Present state is nothing else. How many flip flops it mainly require? Two flip flops. So two flip flops means QA and QB. Am I correct? So this is my present state. Next state. Next, it will have input. Input will be X. Present state. Let's say I am in present state now. State 0 0. Okay, state 0 0. Let's say I am in present state 0 0. So what you can do, you can remember here all these things I have been first converted to binary values. This is 0 0, this is 0 1, this is 1 0, and this b is your 0 1, c is your 1 0 1 0, b is your 0 1, c is your 1 0, a is your 0 0. Okay, like this you can has do this your ways. So where do you have to do here? This you have to do here. This table will come up here after state assignment. Okay, so after this what you are doing here, you can check for input x equal to 0. Now I am in present state 0 0. Okay, where I will go? I'll go to actually next state. Where I will go? I'll go to actually next state. So where, which next state I'll go? What is that next state? Next state will be nothing else my qa plus 1 and qb plus 1. Okay, qa plus 1 and qb plus 1. Now check it. If I am at present state 0 0, see here, and my input is 0, where I am going next state? Next state I am going to 0 1. I'm going to where? I'm going to 0 1. Okay, that only I'm writing. I am at present state 0 0. My input is 0. I'm going to 0 1. Now my input is 1. Where I will go? I'll go to again 0 1. So my present state is 0 0. If my input is 1, again I'm going to next state 0 1. Okay, and what is my flip flop input? Flip flop input will be how many flip flops here? Two flip flops, TA and TB will be my flip flop inputs. So how this flip flop input behave? Depending upon this. If present state is 0, next state is 0, my T is 0. Present state is 0, next state is 1, my T is 1. Present state is 1, next state is 0, my T is 1. Present state is 1, next state is 1, my T is 0. Accordingly, I can just do it. So here, present state is 0, next state is 0, TA 0. Present state is 0, next state is 1, TB 1. Present state is 0, next state is 0, TA 0. Present state is 0, next state is 1, TB 1. Simple. Okay, and what is my output here? My output will be Y. What is my output here? For x equal to 0 as well as for x equal to 1, my output is 0. That only I am writing over here. For x equal to 0, my output is 0. For x equal to 1, also my output is 0. Okay.
Sir,
Now I move to the, yes, any doubt?
sir, can you explain this flip-flop inputs once again?
Flip-flop inputs here I am getting actually. Here, you can see this is my present state, this is my next state. This is T flip-flop I have taken. T flip-flop excitation looks like this. Present state, next state. If my present state is 0, next state is 0, I am getting T input is 0. Similarly, you can see my present state is 0, QA present state. Next state is QA plus 1, next state is 0, 0, 0. At that time, what is my T input? T input is 0. Are you understanding? Present state is 0, next state is 1. What is there? What I am getting? 1. So present state is 0, next state is 1. I am getting 1. Like this way. Present state is 0, next state is 0. I am getting TA 0. Present state is 0, next state is 1. I am getting TB 1. Did you understand now? Hello. Did you understand?
Yes, sir.
Okay, so now I move to the next state. Next state is what? My next state is B, which is 0, 1. For input is 0, I am in the next state 1, 0. So input is 0, I am in the next state 1, 0. And input is 1, my next state is again 1, 0 only. Input is 1, I am in the next state 1, 0 only. Okay, so now tell me what is TA? Present state is 0, next state is 1. My TA is 1. Present state is 1, next state is 0. My TB is 1. Okay, present state is 0, next state is 1. My TA is 1. Present state is 1, next state is 0. My TB is 1. Okay, do you all understand? Now, what is my output? For input x equal to 0 or input x equal to 1, my output is always 0. So, for both the cases, my output is 0. Okay, do you all understand? Now, I move to the next state, which is 1, 0, C state. Okay, now I move to the C state, 1, 0. So, if input is 0, I am in 1, 0. If input is 1, I am in 0, 0. For input is 0, I am in 1, 0. For input is 1, I move to 0, 0. So what is my TATB? Present state 1, next state 1, 0. Present state 0, next state 0, 0. Present state 1, next state 0, 1. Present state 0, next state 0, 0. So from where I am getting? From this excitation table of the T flip-flop, I am just obtaining this flip-flop inputs. Okay. Now what is my output? For input 0 and output input 1, my output is 1. For present state C, my output is 1. So that I am writing here 1, 1. Okay. Do you all understand or any doubt on this excitation table?
Sir, once you repeat this output, no?
Output is very simple. You can see I am at present state A, means I am at present state 0, 0. Whatever may be my input, what will be the output? 0. That only I have done. I am at present state A, means present state 0, 0. Whatever may be input 0, my output is 0. Input 1 also, my output is 0. Similarly, let's say I am in present state C. C. For x equal to 0, I am having output 1. For x equal to 1 also, I am having output 1. So that only. I am at present state C. Okay. For input 0, output is 1. For input 1 also, output is 1. Understand? Did you understand now? Hello.
Yes, sir.
Okay. So you can see here after this step number 6. So step 6 is what? K-map simplification you have to do. For what? For which? What you have to do? You have to find out the flip-flop input functions and the output functions. Okay. So you have to do K-map for flip-flop inputs to find out flip-flop input functions and output function of the circuit. Okay, so first I am doing for the K-map for flip-flop input, K-map for TA. I am doing. What is TA? Here, what are the K-maps I have to do? TA, TB, and Y. 3 K-maps I need. And how many inputs are there? You can see my inputs are QA, QB, and X. Okay, so I will be having 3 inputs. So obviously 8 number of cells. So these are my 8 cells. Okay, QA, QBX, QB bar X bar, QBX bar X, QBX, QBX bar. Okay, and this is QA bar QA. Okay, and we know that what are those minterms? You can see this is my minterm 0, minterm 1, minterm 2, minterm 3, minterm 4, minterm 5. And what are these minterm 6 and 7? Minterm 6, minterm 7 are don't cares. Remember. Okay, in the K map, you need to put don't care for minterm 6 and 7. Okay, so here you can see TA 0011, 0011. Next, 01, 01, and other two are don't care. Simple. Okay, now you can group it. This is one of the grouping I can do, and I can do this pay. Okay, so here I will get actually QB. Okay, am I correct? QB, and from here I can get QA X. Yes, correct. So TA will be mine QB QA X. Okay, so this is my TA. Similarly, I can do for TB. Again, it's a three variable KMF. Okay, this is my QA, QBX, QBX bar X bar, QB bar X, QBX, QBX bar. This is my QA bar QA. Okay, and I can put those 7 and 6 and 7 are don't cares. Okay, and here you can see 111100. So you can see 111100. Okay, so here how the grouping would be? The grouping would be like this. One quad. Okay, here what will get? QA bar. So my TB is QA bar. Okay, now similarly I can do for the output function, which is Y. Again, it's a three variable KMF. I just has going for this 8 cells. So this is my QA, QBX, QB bar X bar, QB bar X, QBX, QBX bar. This is my QA bar QA. Okay, and I can put those values over there. So this is 0000011. Okay, 0000011. Don't care. Okay, so for this I could have this grouping. Okay, and here I'll get QA. Am I correct? So Y will be my QA. So now this is I have got all these output functions and input function. Yes. Then I go for the last step, step number 7. So step number 7 is logic design. Okay, sequential logic design. So for that, what you have to do, as I told you, I just require how many number of flip-flops? I require 2 flip-flops, which are actually called T flip-flops. Okay, this is my flip-flop A, and this is my flip-flop number B. And I have told you this I am doing for clocked sequential circuits with synchronous. So I have taken clock pulse here, synchronous clock pulse. Okay, so this is my clock pulse, and this is my TA, this is my QA bar, this is my QB bar, this is my TB. So you can see over here my TA is nothing else. What I have got? TA is nothing else, QB or QAX. Okay, so I can take here QAX and your QB I can take and perform the OR operation, and I can take to TA. So this is my QB. Okay, next what is TB? TB is nothing else. I have got QA bar. TB is QA bar. So I can take here QA and take a or not gate over here and connect it to TB. And what is my output? My output is QA. So I can, this is my QA. I can take from here and take that. This is my output Y. Okay, do you all understand? So this is my sequential logic circuit, which has been designed from the given state diagram. So this is my state diagram for this particular logic circuit is this one. Do you all understand? Or any doubts, students? Please let me know immediately. Otherwise, we'll go for the next one immediately. Any doubt? Ninsika, are you there? Nimsika, are you there?
Yes, sir.
Did you understand?
Yes, sir.
Okay, good. So we'll move to the next part. One more question we'll do. After that, I'll tell you different questions. Let's say one. Okay. So let's say this question: design a clocked sequential circuit for the state diagram given. Okay. So here the state diagram is given like this. I suggest everybody do this, students. If you won't practice, it's very tough, students. I am telling you. You need lot of practice for it. Surely one 10-mark question you can expect from it. So this is little tough question, students. You have to do yourself. Okay, so these are type of questions will come, students. Please try to understand and do yourself. I'm saying, otherwise, pakka you cannot able to attend in the exam. Okay, so this is the question given to you: state diagram. By looking into this state diagram, tell me what type of model is it? It's a Millet model. Am I correct? Millet model. In the Millet model, you can come to know that this is your state, and this is your input, and this is your output. Okay, so obviously there are how many states here? A, B, C, D, and D. 5 states. Okay, do you all understand now? So now what I'm going to do in the step one is I have to obtain the state diagram from the given circuit information, that is state diagram. Okay, so from this I'm going to do state table. Sorry, I've made a mistake here. This is state table. I have to get the state table from the given state diagram to me. Okay, so here you can see how many states will be there. Obviously in the state table, what are the present state? Okay, so obviously what are those present states actually over here? My present states are here, 5 states. What are those? A, B, C, D, and E. 5 states. Am I correct? A, B, C, D, E. Okay, by looking into this, you can say that this is one state: C, E, D, and B. A, B, C, D, 5 states. Okay, so I will move from present state to next state. Okay, so what would be my next step? If my input is 0, I am going to B, state B. Now I am at present state A. If my input is 0, I am going to state B. Now if my input is 1, I am going to state C. Okay, for the next state I would have two things. One, for input is 0, I am going to one of the state, and for input is 1, I am going to another state. Am I correct, students? So this would be my next state. Now what would be I have to do? Output is also Y. For input is 0, I would have output 0. For input 1, output 0. Okay, for input 0, output something. For input 1, output something. So this is the way I can has to frame it. Okay, now where I am at present state A. Now where I am at present state A. So tell me, if my input is 0, where I am going? I am going to state B. So I am moving to state B. So now input is 1, I am going to state C. You are seeing the arrow. Input is, next state is C. And for input is 0, I am having output 0. For input is 1, output 0. So both the cases I have output 0. Are you understanding? So now I am in which state? Let's say I am in state B. Now I am in this state. For input is 0, I am going to state D. For input is 1, I am going to state E. So input is 0, I am going to state D or state E. So input is 0, what is my output? Output is 1. For input is 1, output is 0. For input is 0, output is 1. For input is 1, output is 0. Okay. Now, with where I am at present state C. Let's say I am here now. For input is 0, I am at this own state C, and for input is 1, I am going to state D. Are you understanding? So C, D. Okay. Now what is my output? For input 0, output is 0. For input 1, output is 1. Okay. 0, 1. Okay. Are you understanding? Now I am in which state? D. State D. Okay. Now I am in state D. Let's say I am now in state D, in this state. So in this state, if input is 0, I am going to which state? Input is 0, I am going to state A. Okay. If input is 1, I am at my own state. Okay. Input is 0, state D, otherwise own state. Okay. At that time, what are my outputs? For input 0, my output is 0. For input 1, output is 0. So both the cases, my output is 0. Okay. Now at which state I am? E. Let's say I am at state E. Now I am in this state. Okay. For input 0, I am going to C. Okay. For input 1, I am going to D. C and D. And what are my outputs? For input 0, my output is 0. For input 1, output is 1. 0 and 1. So this is my state table, student. Okay. All of you understand? Did you all understand the state table? Very simple. Any doubt? Please let me know. Himabindu, did you understand? Okay, Himabindu, did you understand?
Yes, sir, understood.
Okay. So now what I'm going to do, step 2, I'm going to check, is there any state reduction possible or not? For that, I'm going to see the state table and I'm going to recognize, is there any states have same next state and output. Just check here, state C, next state is CD output 01. For state E, next state is CD01. Okay, are you understanding? For here, next state E, C. For state C and E has same next state and output. Am I correct, students? Do you all understand? So what I am going to do, I am going to reduce this E, remove this E. So my reduced state table I am going to draw now. Okay, are you all understanding what I have done here? I have just made this E removed because C and E has same next state and output. C and E has same next state and output, so I can remove this. Okay, so if I remove E, then you can see over here anywhere present E is present. Yes, here E is present, but I have removed E from my design. So I just has to replace this E with C. Am I correct, students? So what I have done here, I have done extra thing here that since I have removed E from my design, because here state C and state E has same next state and output, so E does not exist now. If E does not exist, if anywhere present E, I am just going to remove it and I am replacing it C, because state C and state E are equal here. So in order to, if I keep more state, obviously I require more number of flip-flop to design, which will be not proper design and which will be cost effective, not cost effective design, which will be high cost design. So in order to remove that, what I have done is, since the state is reduced, So I am going to remove all the states with the replaced state. Okay, here I know that my state C and state E are equal because my next state and outputs are same for C as well as E. That's why I remove E. Since E removed means I have replaced E with the C. Okay, so how my reduced state table? My reduced state table looks like this: present state, here it is next state, here it is output Y. So present state, it has actually for next state for x equal 0 and for x equal to 1. Similarly for output x equal 0 and x equal to 1. Let's say I am in my present state. Let's say now A, B, C and D. 4 states only. E get removed. Am I correct? So for that, what I have got, just I have to copy, nothing else. A, B, C 0 0, B, C 0 0. Next B will be D, C 1 0, D, C 1 0. Next C would be C, D 0 1, C, D 0 1, and D will be A, D 0 0. A, D 0 0. Are you understanding? So this is my state table. Is there anything else reduction possible, students? No. Now you can see that there is no reduction is possible. So this is my reduced state table. Okay. Do you all understand? Now step number 3. Any doubt on this reduced step table? Please let me know. What is step 3? My step 3 is state assignment. So here you can see state assignment. It has how many states actually? 4 states. 4 states means it's not to assign this. We need 2 number of bits. 2 to the 2. 2 to the 2 means 0 0 0 1 1 0 and 1 1. So I can assign 0 0 to A, 0 1 to B, 1 0 to C and 1 1 to D. Very simple. So assign binary values to states. So that is your assign binary values to the states. Okay, for A 0 0, B 0 1, C 1 0, D 1 1. Okay, so like this I have assigned my states. Okay, any doubt? Now, step number. So after that, what you need to do you know, students? You just has to make this state table here. So after this assignment, you have to make this present state, next state. So I'm just doing it because it will be useful for you. X equal 0, x equal to 1. Next output Y, x equal 0, x equal to 1. Okay. So there are how many states? A, B, C, D. A, B, C, D means 0 0, 0 1, 1 0 and 1 1. Okay. For x equal 0, what is the state? B. B means you have to write down. You can see here. B is 0 1. And next state is x equal 1. C. C means 1 0. And output is 0 0. Very simple. Now 0 1. Present state is 0 1. 0 1 B. D x equal 0 D. D means 1 1. And next C. C means 1 0. And output 1 0. Okay, very simple. Next x equal 0 C. C means 1 0. And D means 1 1. And output is 0 1. Simple. Okay. Next last one. I can have this A. A means 0 0. D means 1 1. Output is 0 0. So this is my after state assignment. This would be my state table. All of you understand? Very simple. Okay. Next step number 4. What is step number 4? You have to find out the number of flip-flop required and type of the flip-flop. Type of the flip-flop. Okay, so you know that formula 2 to the n is greater than equal to n. Here n is number of states and here n is number of flip-flop. Okay, so from this I came to know that I have after reduction how many states I have? 4 states. So obviously 2 to the power n is greater than equal to 4. So how much will be n equal to? So we need actually number of flip-flop required to me to design this particular sequential circuit is 2. So now which type of flip-flop we can take? Your wish. So if there is not given in the question, it's not given to which type of flip-flop is you have to design for this clocked sequential circuit. Your wish you can take. It's easy to take type of flip-flop is D flip-flop. Type of flip-flop is, let's say I'm taking D flip-flop. Okay, are you understanding? So this is my step number 4. You have identified the type of the flip-flop and number of flip-flops required. Now step number 5. What is step number 5? You have to find out the excitation table. Okay, excitation table and the output table. So you know that excitation table of D flip-flop is Qn plus 1 and D. So obviously you know that this is 0 0 0 1 1 0 and 1 1. Why I have taken D flip-flop? Because whatever Qn plus 1 is same as D. So 0 1 0 1. Okay, that is the reason I have taken it. Okay, so because Qn plus 1 is D, that is the reason I have taken. It's easy for me to find out the circuit excitation table. Now what you have to do, you have to find out the excitation table of the given circuit. So here in the excitation table, what will be the students? One will be present state. In the present state, what it will be there? It is QA and QB. Why it is QA QB? Because there are two flip-flops, so two flip-flop outputs QA and QB. Am I correct? Now input will be X. Either input is 0 or input is 1. Am I correct? Now next state. So next state will be what? For input 0, it has one state. For input 1, it has another state. So for that, I have just written the next state QA plus 1 and QB plus 1. Next flip-flop inputs. So flip-flop inputs is what? DA, DB. Simple. Two flip-flops, two inputs, DA, DB. And finally, the output. Output is Y. Okay. So this would be my excitation table I'm going to frame now. So QA QB 0 0 input is 0. So see here I am at present state 0 0. For input is 0, where I am going 0 1, and for input 1 I am going to 1 0. Okay, 0 1, and for input 1 I am going to 1 0. Are you understanding? For state 0 0, for present state, if I am at present state 0 0, for input 0 I am going to 0 1, for input 1 I am going to 1 0. And what is my D flip-flop inputs? DADB. DADB is nothing else, whatever the next state, the same. I'm just going to copy whatever the next state, because you can come to know that Qn plus 1 and D are similar. Whatever the next state, that will be same with the D. So I have just whatever my next state, the same will be my flip-flop inputs. Okay, because I have taken the D flip-flop to design my particular sequential circuit. Okay, now what is my output? My output is for input 0, output is 0, for input 1, output is 1. That only I am going to write down here. Input 0, output is 0, for input 1, output is also 0. Okay, now I am at which state? 0 1. Okay, for input 0 it will be 1 1, for input 1 it is 1 0. Now I am at which state? 0 1. For input 0 I am going to 1 1. For input 1 I am going to 1 0. Okay, so and what is D flip-flop? Same, you have to just copy 1 1 1 0. And what is my outputs? My outputs are for input 0 my output is 1, for input 1 output is 0. Input 0 output is 1, for input 1 output is 0. Now I am going to which state? 1 0. For input 0 input 1, 1 0, for input 0 1 0, for input 1 1 1. Same thing, 1 0 1 1. Okay, and what is my flip-flop input? Same, I'm just copying 1 0 1 1. What is my outputs? My outputs are for input 0 output is 0, for input 1 output is 1, for input 0 output is 0, input 1 output is 1. Now I am going to the next step 1 1. For input 0 input 1, for input 1 output is 1, for input 1 output is 0. Input 0 output is 0, input 1 output is 0. Now I am going to the next step 1 1. For input 0 input 1, for input 0 output is 0, for input 1 output is 0. Now I am going to the next step 1 1. So you can see what is my outputs next states here. For input 0, my next state is 0 0. Input 1, my next state is 1 1. 0 0 1 1. Okay. And what is my flip flop input? Same. I've just has to copy this. What is my outputs? My outputs will be input 0, output is 0, input 1, output is 0. So both the cases my outputs are 0. So this would be my excitation table and output table. Understand, students? It's very simple. This is my excitation table of the circuit or output table of the excitation table of the circuit. Now what I am going to do? Step number 6. The step number 6 is nothing else. You need to do the KMF simplification to find out what are the things you will need to find out. You have to find out flip-flop inputs. So flip-flop inputs, what are the things you have to find out? DA, DB, and you have to find out output of the circuit. What is output of the circuit? Y. So for all these things, you have to do KMF simplification. For that, I'm just doing here DA. So it's a 3 variable again. I'm just going to have 8 cells. Okay, this is my QA, QBX, QB bar, X bar, QB bar X, QBX, QBX bar, next QA bar, QA. Okay, so you can see here my DA is here 0 1 1 1. So I'm just going to put those things 0 1 1 1. Next 1 1 0 1. 1 1 0 1. Okay, so what to do here mainly, how to group it actually, students? So you can group it like this. You can have one grouping like this and one pair and another pair. Am I correct? So for this I have got actually QX, only X. Okay, for this I have got QB bar, QB. Okay, QP bar, am I correct? Sorry, QA bar, QA bar, QB. Okay, for this QA, QB bar. Okay, so what I have got DA is my nothing else X or QA, QB bar or QA bar, QB. So which is nothing else X, QA, X or QB. Simple. Okay, so now I am going to find out for DB. For DB again, it's a 3 variable. I have just taken 8 cells for to do the KMF simplification. Okay, so this is my QA, QBX, QB bar, X bar, QB bar X, QBX, QB X bar. Okay, this is my QA bar, QA. Okay, so now I'm going to put those values over there. 1 0 1 0, 1 0 1 0. Next 0 1 0 1. Okay, 0 1 0 1. Okay, so here what I can do, this is one grouping, this is another grouping. Okay, from this I have got QA X, from this I have got QA bar X bar. So we have got DB as QAX, QA bar, X bar. So this is nothing else my QA X nor X. Am I correct? So my DB is QA X nor X. Okay. So finally output I had to find out. For output again it's a 3 variable KMF. I just has to do this 3 variable KMF. So this is my QA, QBX, QB bar X bar, QB bar X, QBX, QBX bar. Okay, so this is my QA bar, QA. Next, what I need to do here, I just has to put those Y values. Y values are here 0 0 1 0. So 0 0 1 0. And next 0 1 0 0. So 0 1 0 0. And how the grouping? This is one grouping, this is another grouping. Here we got QA, QB bar X. Here we got QA bar, QB X bar. Okay, so YA will got as like this: QA, QB bar X plus QA bar, QB X bar. So this is my output y. Okay. Now what I have to do? I have to do step number 7 is I have to do the logic design. So how to do that logic design? Very simple. You would be have actually 2D flip-flops. Okay. This is my flip-flop A, D flip-flop A, and this is my D flip-flop B. Okay. Here what I'm doing actually here DA, this is my QA bar, this is my DB, QB bar. Okay. So and we know that this is clocked sequential circuit, synchronous clocked sequential circuit. I have taken clock pulse, synchronous clock pulse, and my DA is what? My DA is nothing else my X or QA X or QB. Okay. I have taken it like this QA X or QB with X or get with X. So I have taken a or get here as X, and this will be or function connected to DA. Understand? Next DB. DB is what? DB is QA X nor X. So I am going to take QA X nor X. So I have taken here X nor operation and connected to DB. Okay. Now what I am going to do? I am going to find out the output Y. Y is nothing else QA QB bar X. So this is my QA QB bar X and get. Okay. Similarly, I have taken QA bar QB X bar. QA bar QB QA bar QB X bar. I have taken this as an AND gate and connected here to get the output Y. Okay, so this is my logic circuit, students. Okay, so this is the logic circuit, which is nothing else clocked synchronous sequential circuit for this given state diagram. Okay, do you all understand, students, or any doubt? Tell me. So do you all understand how I have designed the circuit actually, or any doubt? Any doubt on this?